110 is, they're calling it modeling. Guys, come on. Thank you. 110, they call it modeling. And if you guys remember from last year, in Algebra 2, we did it those modeling units kind of towards the end where we kind of put everything together. You use the calculators for the regressions and all that kind of junk. We're going to kind of stay away from the regression formulas and all the calculator nonsense for this at this time because we're not really worried about it right now. All we're worried about in this unit in 110 is going to be talking about direct and inverse variation. Direct and inverse variation is stuff that you guys did last year in Algebra 2. Not only was the direct variation stuff that you've done before, but direct variation, it was basically slope. Okay? This wasn't anything new to you. What's going to be a little bit different when they show you guys now in terms of in pre-calc is just how they write it. What we had was direct and inverse variation. So real fast, if you remember direct variation, if it said like y varies directly with x, that meant y equaled k times x. That value of k was some constant. We called it the constant of variation. What you guys did is we would have problems where it say like y varies directly with x. When x is 8, y was 3. And you would figure out what the variation was and rewrite the equation. Where you'd have 2 of the 3 variables and you'd solve for the third. That's all it was. Same thing with the inverse variation. It said that y was inversely with x. All you had to do was what? Do you remember? Reciprocal, exactly. And that's all it was. The inverse variation was y equals k over x. And that's all that was. Okay. You guys did that last year. You actually probably will remember the next slide, I bet, hopefully. The next one that I have was that write out in your Algebra 2 books that looked like this. Remember that?
Oh, yeah.
Y varies directly with x.
Oh, yeah.
K is that constant. I'll show you. I have an example for you. That value of k is just a constant we're going to solve for. Okay. We're writing a model, write an equation about variation. We're going to figure out that k value and then write the equation. It's think of it this way. Last year, you guys did something with intercept form with parabolas, where you'd write the equation in intercept form when you had zeros at 4 and 3 and an ordered pair of 2, 1. What you guys did here, these were the zeros, the p and q here. What you would do here is that you have 4 of the 5 variables. You were solving for a, and then you just rewrite the equation. It's the same thing, but a lot easier. A lot easier. So if you had y varies directly with k times x, inversely k over x, jointly with x and y, that means there's 2 things that are being multiplied together. So it's k times x times y. Varies inversely with the square of x. Well, if it's inverse, it's flipped, and square of x is just x squared.
Whoa.
I know. And then, let's see, z varies directly with y and inversely with x. So k times y divided by x. That's it. I know all of you guys did these. And they were really, really easy. Okay? It's just if you have 3 of them, that's all.
Oh.
That's all it is. It's just you can have more than one going on at the same time. Alright? And what you guys would do, go back, sorry. What, no, I'm just reminding you guys of what it looked like. And when you did this last year, it would be the following, and I'll give you the example that I was talking about. For example, if I say that x and y vary directly, actually, let's do inverse. Sorry, let's do inversely. we'll say x and y vary inversely.
Is this going to be on the test?
Yeah, this is kind of how it looks. It's when x is 5, y is 2, y is -2. Find x equals 2. So if you're looking at it, it says x and y vary inversely. When x is 5, y is -2. What that means is that there's some equation, y equals k divided by x. You know 2 of the 3 variables here. What's y? -2. You don't know k, but what's x? 5. How do you solve for k? Okay, deep breath. -2 times 5. -10.
Do you think I was going to say positive 10?
No, it's just accident.
Well, you really confused me like I was
No. So what we're doing here is we're figuring out what that constant of variation is. It's -10. Which means if you go back to rewrite the equation, the formal equation that has these points would be y equals -10 divided by x. So the last part would be, well, what's y if x is 2? -5. That's all it was. And you guys did this. This was ridiculously simple. It's just you haven't seen it in a year. That's all. All right? That's all this is. You'll know a couple of the, 2 of the 3 parts, and you substitute back in and rewrite the equation. Oh, first thing it would say, x and y vary inversely when x is 5, y is -2. What is x of 2 then? You're finding the equation to use for x is 2. That means y would be -10 over 2, which is -5. So my answer would be yeah. Okay? So when we go through this then, the only new term that they're going to say instead of varies directly or varies inversely or something like that, it'll say this. Proportional. That's it. That's the only new thing that they say here, is it'll be proportional. So you're doing all the same work, but instead of saying
Man.
thank you. So you get this as a, sorry. You know this, for direct variation, y varies directly as x. It means the same thing, y equals k times x. The only new way that they say it is y is directly proportional to x. That's the only new way of saying it. This means the same thing, y equals k times x. The only thing that's new, direct variation, y is directly proportional. That's it.
So not a variation, it's a proportion.
Yep, directly proportional. It's the same thing. That's all. And then when we get into the inverse, there'll be one little change for that too, and you'll see that in the next one. Just remember that this proportion, it says it's directly proportional, means it's direct variation. Okay? Directly proportional, direct variation. Directly proportional.
So all of those are direct.
What's that? The ones I was showing you earlier?
No.
Yes, this all means direct variation. For y varies directly as x, y is directly proportional x, they still have the same formula. Y equals k times x. Where that value of k, instead of being the constant variation, it's now the constant of proportionality. It just changed names. Same meaning. It's a synonym. Take that to your English class. Look at that. Trying to sound smart. Right. And then if you go to direct variation, same idea with the nth power. It's like when we had the one where y varies directly with the square of x. It would have been y equals kx squared. Well, this is Y varies directly with the nth power of x.
So what is it?
It just means y equals k times x to some nth power, whether it's the cube, squared, fifth root, fifth power, whatever. All means the same thing. They're still doing the same idea. Y equals k times x to the n. Direct variation with the nth power. Instead of saying the square of x, they'll say the nth power of x. That nth power could be anything. N could be any number. Notice they're still using the term direct proportional. Directly proportional. That means you're multiplying straight across, just like we did with the direct variation. Okay? It's the same thing. It's the exact same thing. Like I said, it's the same thing. Directly proportional, direct variation. Y equals k times x. That's it. The other one I think is the inverse one. Instead of saying directly proportional, it says inversely proportional. It's the same thing. Alright? Same deal. Y equals k over x for the inverse. Alright? Inverse means it's just the reciprocal property. That's all. The only thing that's changed is the word proportional. That's it. Everyone else is cakewalk. Hopefully. I don't think it would be very easy to walk in cake. It
What
depends.
if you're walking around?
Are you going the distance? Are you going for speed? Are you all alone in your time of need?
I feel like this is
I don't know what-
experience.
At 7 o'clock at night
Cake.
on Tuesday.
Going the distance, walking around.
Not really sure what you're talking
What?
about.
Thank you. At least one person who get it, I hope. You've never heard the song? He's going she's going the distance. She's going for speed. She's all alone. All alone in her time of
No.
need.
The song?
Yeah. maybe
What's
we
the
could
song
play.
called?
Going the distance.
By
Can you
who?
play it?
Cake.
Oh.
Can you play it?
Never played it.
Not now.
I mean, it makes
Joint
sense.
variation.
If
Same
you
deal.
heard the song, it would make sense.
Like we did earlier, we had varies jointly, where it was like z varies jointly with x and y. It was z equals k times x times y. Z varies is jointly proportional. Same deal. Z times k. Z is k times x times y. All I'm trying to show you guys here is this proportional part. You're doing the same thing as direct or inverse variation stuff. Okay? It's just the same thing. So this should be non-scary. Alright? Yeah. Absence of scariness. Non-scary.
Okay, so what does that look like? Is he, oh, it's right there. We usually wrote them on the bottom.
Oh, I know. Well, it's the same thing. It's z equals k times x times y. So example-wise, what'll happen here is that we'll get into a little bit of the word problem. But here's the thing. All you have to know is what they're saying. They're stupid easy. In Pennsylvania, the state income tax is directly proportional to gross income. State income is directly proportional to gross income. So state income is directly proportional to gross income. Y is directly proportional to X. See how it's the same wording? It's the same thing. You are working in Pennsylvania and your income tax deduction is $46.05 for a gross monthly income of $1,500. Write a mathematical model that gives Pennsylvania state income tax in terms of gross income. Basically, that means, well, state income tax is directly proportional to gross income. Well, your income tax is 4605 is some constant times 1500. That's it. How do you solve for K? Divide. So if I divide this out, yeah, if I divide that out, sorry.
Is that the new one? Are those new calculators?
No, that's.
Oh, it's the new operating system for the 84s.
Yeah, I don't
It's
like it.
well, this isn't what you have. So your variation is 0.037. So there's your value of K.
Oh.
So you find that value of K, and then you just rewrite it, just like you would earlier. That means your state income is equal to 0.0307 times your gross monthly income. Therefore, you could figure out how much you're paying in taxes, whether you're making $1,500, $15,000, $5, whatever. If it's just a linear setup like this, and not a sliding scale. We're not done yet. So my final answer here in terms of the would be, well, you can write it as y equals 0.0307 x. Or you want to leave it in terms of s and g. This is a percentage. Everybody okay? Understand that? What's that? No, it's a decimal version of the percent. So this is, if you think about it, this is 3.07% income tax rate. If you want to think of it in terms of what it really is. Do you know that you can take your income in Illinois, or basically or any of your paychecks, what your gross is and what your take home is about 20% off, rougher, give or take. Not so much taxes, but just how things are sheltered through with insurances, and if you have to pay for, insurance, if you're paying for retirement, things like that. It's
So wait,
just a little wash.
you're taking home 20 or you're gonna
Oh, you
stay
take off
away?
about 20% of
So
what.
you're keeping like 8.
Right. Let's try another one. Okay. The distance the ball rolls down an inclined plane is directly proportional to the square of the time it rolls. Very good, sir. Very good. Just like Quentin said there. Y equals kx squared. The distance it rolls directly proportional to the square of time. T squared, or just like you were saying, y equals kx squared. And then put it in terms of what you're dealing with in the problem. In this case, we're dealing with time and distance. What's that?
Wait,
You can if you
D
like.
is-
Mhm.
So, but during the first, second ball roll, 8. You have to do 8 times 3.
Well, take a look here. Write the equation. Well, we wrote the equation in terms of distance and time. So they'll want you to go with D and T. Okay. How far will the ball roll during the first 3 seconds? Well, we have to figure out the K value. Well, during the first second, the ball rolled 8 feet. So to figure out what K is, 8 equals K times 1 squared.
Oh, I thought it was 3.
Why? Where are you getting 3? I'm looking the first second. I'm looking at this info right here.
You have to do that first.
Yeah, because you're going to figure out what the value of K is. So if I figure out what the value of K is, well, what's 1 squared?
1.
1. What's 8 divided by 1? 8. So what's K? 8. Whoa. So D equals 8 T squared. 80 squared, 8T.
And you put 3 in it.
So if you're writing T, like if you wrote X instead of
T as in time.
Distance to time, it's going to want you to. I know what you're doing. I try to get in the habit of doing it this way so you know which one's going where. So if you want to figure out how far it rolled in the first 3 seconds,
You put T 3 in for 2.
3 in for t, so this is going to be tough here. 8 times 3 squared. So the distance would be 72. I think this is in feet, right? That's it.
Oh, that's
Yeah, it's.
Don't make it hard.
Well, I'm not trying to.
That's what I'm saying. On the test, you always
Well,
do that where you make it like
Yeah, on the
10
test
times
you
harder.
Yeah, that's good.
No, like the homework will be super easy, and then the test will be not anything.
And then you substitute that.
you just have bad memories of the quadratic unit test. Cost goes up, price goes down. What is the price instead of what was X? That kind of stuff. Simple interest for a certain savings account is jointly proportional to time and the principal. So, simple interest is jointly proportional, okay, times 2 other things, time and principal. Simple interest equals something times time and principal. Well, after 1 quarter, 3 months, interest on a principal of $5,000 is $43.75. So to write the equation relating interest, principal, and time, well, interest, simple interest, is some constant times the time and principal. And I believe, I think I actually, the value of time here is in months. So that's, I think I cut that off from the problem there, so I apologize. It'll tell you whether it's going to be monthly or daily or something. So after 3 quarters, so we're going to figure that out. So we have, our interest was $43.75 is K. Well, our 5,000 times 3. What do you get for K? Some number. Yeah, that's it. And then you just re-substitute in. If they're talking about 3 quarters, how many months is that?
9.
Right, because 1 quarter is 3 months, 3 of them would be 9 months.
You didn't say I got points.
I know, but because people are going late. But you see how this is really easy?
Yes.
Okay, it's trying to subside the worriness level. Let me give you guys a couple problems to try. Couple groups. I think the homework sheet that you guys had, if I'm not mistaken, I think those were good. Let me double check here real quick. Hey.
You said you were going to bring it.
11, 12, 13, every other odd. Yeah, 13 through 25, every other odd is like 4 problems. Simple interest there, 25, yeah. Yeah, the assignment for 1.10 on here works. I don't think there should be anything on here that's going to be difficult whatsoever. So it's on 1.10, starts on page 111. Numbers 11 and 12, and then it'll be 13 through 25, every other odd. And then 29 through 65, oops, by 6s. So that means 29, 35, 41, 47. Okay? Really quite simple. Yeah, everything. All right?
All right.
You guys had asked about, what sections we're looking as far as the tests and stuff. I kind of went through everything. and it looks like the test is basically 1, 4, and up. Okay? Because 1, 1, 1, 2, 1, 3 were really simple stuff. So 1, 4 was your difference quotient. It's really the only thing that was new in that. 1, 5 had zeros and average rate of change. 1, 6 was the graphing, the parent function stuff. Same with 1, 7 started to do the describing of these translations, you know, in terms of F and G. How did it go? You know, we did it on Friday when we put those through. Then you had function operations, you know, F of G, F of X, things like that. Then we had inverse. Can you find the inverse? Can you graph the inverse? And then this last little bit, directing an inverse variation with the constants of variation, things like that. The simple interest style problems and write-outs. I honestly don't think there's anything on there that will come as a surprise. There's no tricks. Okay? Graphs, yes. Take a look at that. On number 11, it's doing this, right?
Yeah, inverse would be a
So does that look like an inverse relationship or a direct relationship? I think that's the one, right?
Yeah. I mean, there's not that many dots at all.
It's inversely. Think about the values. An inverse relationship is 1 divided by something. 1 divided by x. 1 divided by 1 is 1. 1 divided by 2 is a half. 1 divided by 3 is a third. 1 divided by 4 is a fourth. It's getting smaller and smaller and smaller. It's just going to the right. That's an inverse
Do
relationship.
we have to plot the points for like
No, you're just using your calculator.
But it says plot the points on a
No, don't block. The guys, I didn't realize it said plot. Don't plot points. Just figure out the table. That's it. Don't worry about plotting points. I think you can do that. I hope you can. Okay? Sir?